Let's take a look at this example. We have resistor R4 which is connected to this point, but other point is connected, we can say, nowhere. That's why at this moment we're supposed to ignore this resistance, because we are interested about the total resistance only. Okay, so if my ohm meter is connected to R1 and this resistor is connected nowhere, that's why I can simply ignore it. Now my ohm meter is connected on the left side, so I have to start solving this problem from the right side. So what I have over here, I'm seeing over here resistance R2 and R3 connected in parallel. Okay, these two resistors are in parallel and in series with this one. So what I'm going to do first, I'm going to calculate the total resistance of these two resistors first. So I say this is R2 3 is equal R2 times R3 over R2 plus R3. This is equal 3 kilo ohms times 9 kilo ohms over 3 kilo ohms plus 9 kilo ohms. So R2 3 is equal 3 exponents 3 times 9 exponents 3 equals divide by 3 exponent 3 plus 9 exponent 3. I'm doing every single step to make sure that everybody knows how to use the calculator. So 2.25 kilo ohms. 2.25 kilo ohms. Please notice that the result of our calculation, okay, is less than the lowest resistance, okay, in this part of the circuit, so it looks that we are doing everything fine. Next, we can redraw the circuit. Okay, so this is my R1 and this is my R2 3. So in order to find total resistance, we simply add these two resistors together. So I have R1 plus R2 3. So R total is equal R1 4 kilo ohms, 4 kilo ohms plus 2.25 kilo ohms. So R total is equal 6.25 kilo ohms. Okay, and this is the solution to my problem.